So again, welcome everybody. My name is Bill Graybert. I am a volunteer board member with Tuleyome. Unfortunately, Jeff can't join us tonight, so I'm taking over the duties. You should be able to see the shared screen I've got that shows some upcoming events for Tuleyome. Not this Saturday, but next Saturday is Lynch Canyon hike. I think I might be going on that too. So we've got Stebbins Cold Canyon Trail Work and the big spring thing on the 22nd. So everybody, please come to the spring thing. It should be a good time. Hopefully we'll have better weather than we did last year. It was a little bit windy and cold, but we're hoping for better weather. Our guest speaker tonight, I also want to point out the QR code on the screen there. If you would like to give a donation, and we could certainly use it, you can use that QR code. You just use your camera on your phone and it'll connect you to our donation web page. So our guest speaker tonight is Dr. Glen Holstein. He is also a volunteer board member with Tuleyome. He has been a professional botanist and biologist, and he will tell you more about his background. Tonight we're going to be hearing about biodiversity, which is very important in our area. We've got one of the most biodiverse areas in the world. Okay, Glenn, take it away, and I'm going to stop sharing my screen, and you guys can share yours.
Well, good evening, everybody. It's a pleasure to talk to you tonight about biodiversity. And it's the number of species or other genetic groups that basically it can be at any kind of area. And that can be just a small tract of land or an entire country or the entire world. And there's a global movement now called 30 by 30 to give enough space for the thousands of species that we share our planet with so that they can survive. And more and more people are appreciating that it's not just us and our domestic animals, but there are lots of other species of plants and animals and mushrooms and kelp out there as well. So this is a map of the world showing where the most plant species are. And you'll notice that they're heavy in the tropics, heavy in warm regions. They kind of follow the mountains in Mexico up, but they also extend into interesting other places. You notice how they wrap around, if you're familiar with the continent of Africa, how they wind around the east coast of South Africa and reach a kind of a peak there around the Cape of Good Hope. There are also some high points in southwestern Australia, a little dab of green in central Chile, a lot around the Mediterranean, and even quite a bit around California.
Use this right here, right here, right here.
And these areas where biodiversity is particularly high and also at risk have been identified by groups like the World Wildlife Fund that are committed to protecting that biodiversity. And you'll notice up in the west coast of the United States, we have the California Floristic Province, which is where we are, indicating that's an important place for biodiversity. And it's one of the 5 Mediterranean climate regions on the Earth. California there in North America, central Chile in South America, the Mediterranean basin that gives Mediterranean climates their name, pretty large one. 2 places in Australia, The biggest one, the most important one, is in the southwest part of Australia. And actually, one of the smallest in area, but one of the richest in biodiversity, is the Western Cape in South Africa. And if you look at a map of the United States to see where hotspots of biodiversity are, hotspots are places where it's unusually high. You notice California really stands out more than most other states. There's another high point in the Appalachians, but overall, California is really the hotspot of biodiversity in North America. And it shows up because we in California are first among states in overall biodiversity and endemics, and we'll talk about what endemics are in a second, plant biodiversity and plant endemics, vertebrate animal endemics. We don't have the largest number of vertebrate animals, but we do have the largest number of vertebrate endemics. We have the largest number of mammal species for any state, and the largest number of endemic animals for any state. And we're also number one in freshwater fish and amphibian endemics. And endemics are species limited to one specific area. And for a long time, we've known that some of these endemics are old and some are new. But a lot of that was based on speculation. Now we can narrow it down much more precisely because of genetics. But the general picture is that if there's a lot of closely related species, they're probably, and spread across different parts of a landscape, they're probably new endemics. But if they have no other close relatives and they're kind of in a place by themselves with no close relatives, that means they've probably been there a long time and are just hanging on after climates have changed and have wiped out their relatives. We'll talk about some examples in plants, but a familiar example might be to some of you what they call a mountain beaver, which is unrelated to any of the other rodents on the earth, and we have it in northwestern California, extending up into the Pacific Northwest. So that would be an example of an old endemic. And we have lots of beautiful endemics here in California, like this one that is in the dry parts that shows up in spring, Calanthus inflatus.
Glenn, sorry to interrupt, but could you define endemic one more time, please?
Yeah, endemics are something that are only found in one particular area. In other words, a California endemic would be something that is found only within the borders of California. We have a plant across the river that is a rare grass that's endemic to Sacramento County, only found in Sacramento County. So you can have endemics at any level. You could have things that are endemic to North America and not found anywhere else. But when we talk about California endemics, we're talking about species that are only found within the borders of California. Here's another one that's actually related to our phyllories, but this is a native relative of phyllories called California macrophylla. And even though the phyllories are abundant, they're non-native. They survive very well with grazing. This one doesn't survive very well. And especially with introduced non-natives, it's being crowded out and has become extremely rare. And that's one of the things we've worked to protect in Berryessa Snow Mountain National Monument, which Tuleyome has created. Here's another one within Moloch Luyak, which we just added to Berryessa Snow Mountain National Monument. This is Allium falcifolium, and it's a native endemic wild onion that likes serpentine. And serpentine is a special kind of mineral that is more common in California than most other places on Earth. And one of the reasons is it's part of the Earth's mantle that has been pushed up in certain places because if you go back far enough, the western coast of North America for a long time was in central Nevada. Well, there were what are called microcontinents or exotic terrains that moved because of continental drift across the Pacific and got pushed up against the former west coast of North America and were welded to it as they hit it. And there were several of these. And because of these collisions being geologically so violent, they actually pushed up part of the mantle, which is the area below the crust that's chemically different from the crust, and to create serpentine deposits both in the Sierra Nevada and in the Coast Range. And this is in the Coast Range at Moloch-Luyak, almost entirely on serpentine. And we have number one mammal diversity of all the states and number one mammal and endemism in all the states. And a lot of this is provided because we have a large number of different kangaroo rat species here in California, mostly in the Southern Coast Range and in the San Joaquin Valley. And the other group that makes us so rich in mammal endemism are chipmunks. We have lots of little mountain ranges, and oftentimes each mountain range will have its own species of chipmunk. So chipmunk diversity is one of the reasons our mammal diversity and endemism is so high here in California. And we actually have one purely endemic bird, and that's the yellow-billed magpie, which we can see right here in Yolo County. Its numbers are down because of being attacked by the West Nile virus. It's not as common as it used to be, but you can still find them. And we used to have other endemics like the California condor, but that's been reintroduced to Arizona, so it's not a pure endemic. Tricolored blackbirds are mostly endemic to California, but there are a few that get north into Oregon and Washington, so it's not exactly as much of an endemic as yellow-billed magpies. But the yellow-billed magpie is a perfect California endemic because it's only found in Central California and nowhere else. And one of our endemic amphibians is the western spadefoot, which likes our vernal pools here, areas that are wet in the springtime and then dry out. And during the time it dries out, it goes into estivation, gets away from the dryness, and stays underground until it gets rain again. Well, if you look at the mountains of North America, you can see that we're kind of shut off from eastern North America by the Rocky Mountains, very high range, and several other ranges, including the Sierra Nevada. And that's one reason our climate is so different from the climates in eastern North America. You can also see mountains in Mexico along the west, and those are tropical mountains, and monsoons move north from those mountains and bring somewhat tropical conditions into southeastern Arizona. The monsoon rains provide the primary rainfall, at least in summertime, to southeastern Arizona. But we're cut off from that monsoon effect in our region, which is not a Mediterranean climate phenomenon, by that great rift that creates the Gulf of California and then the Imperial Valley and the Valley of the Colorado River. So you can see that green means that that's low country. It's a barrier for the tropics moving up through the mountains of Mexico into southeastern Arizona. Well, if you look at vegetation, it's pretty simple east of the Rockies. Forests in the east, grassland in the Great Plains. And then as you go west, it gets more and more complicated. And when you get out to California, it gets very complicated. You don't see big stretches with the same color. You see lots of different colors winding around each other, which indicates we have a lot of vegetation diversity as well out here in California, which is one thing that adds to our animal and plant diversity.
little bit closer.
Well, if you look at the geology and the topography of California, see some interesting things. Well, we've got a huge mountain range along our eastern edge, the Sierra Nevada. And if you notice, the mountains get higher as they go south, which is a kind of an interesting phenomenon. They're highest in the south. And then if you look to the east of the southern Sierra Nevada, there's a series of valleys, including one over almost up against the border of Nevada that is Death Valley. And we'll see more pictures of Death Valley in maps coming up. It's an important area to keep in mind because it's very distinctive. Then we have a lot of series of mountains to the southeast, scattered in the desert parts of southeastern California. We have right about, a little ways north of Lake Tahoe, up around Lake Elsinore, the Sierra Nevadas come to an end and a new range starts, the Cascade Mountains. And the Cascades are different geologically from the Sierra Nevada because Sierra Nevada is mostly granite. The Shasta, the Cascade Mountains are mostly volcanoes. And there's a lower area to the east called the Modoc Plateau that also has a lot of volcanoes. And then way up in the northeastern corner of California, there's an island of mountains called the Warner Mountains. And then if you go out to the northwestern corner of California, you see another range of mountains, very complex, called the Klamath Mountains. And geologically, they're a little bit like the Sierra Nevada. They have quite a bit of granite, but they also have lots of other unusual geological features. But as you go south from the Klamath Mountains, you get into the northern Coast Range, which extends getting lower and lower all the way down to Yolo County a little ways. And then south of the San Francisco Bay, you have a series of lower Coast Range mountains until you get way down in Santa Barbara County, which is just above those islands that you see. Do I have a question there? Okay, and as you see, when the Sierra Nevada come together at the south with the Coast Range, and to the east of that where they come together, there are several high mountains. The San Gabriel's in Los Angeles County, San Bernardino's in San Bernardino County, each one showing up as dark brown. The San Jacinto's in Riverside County, each one separated from the other, but each one very high, over 10,000 feet. And then you have the Peninsula Range extending south to the Mexican border, once again, geologically, very much like the Sierra Nevada. And then to the east, that great rift that is the northern end of the Gulf of California, where the Salton Sea is, a coastal plain to the west of the Peninsula Range, including Orange County, Los Angeles County. But if you notice in Los Angeles County, there is a peninsula sticking out, and that's the Palos Verdes Peninsula. Well, to the south and west of the Palos Verdes Peninsula are a group of continental islands. And continental islands are places that are separated from the continent by deep water, so that even when the oceans were lower because so much water was tied up in continental glaciers that the sea was lower, it wasn't low enough to not isolate those islands. The islands have been permanently isolated by deep water from the mainland. Well, there was actually one of these channel islands that formerly made up that peninsula, but when those mountains in like the San Gabriel Mountains started rising up relatively recently for mountains, there was so much erosion and sediments that came down out of those mountains that they connected that island that is now the Palos Verdes Peninsula to the mainland. And you can tell of it, its relationship to the Channel Islands because there's a plant called Crocosoma californica, a beautiful shrub with big white flowers that almost is only found in the Channel Islands. The only place it's found on the mainland is on the Palos Verdes Peninsula. Well, you notice in the middle of California is one of the biggest flat valleys on Earth that is completely, almost completely surrounded by mountains. That's the Great Central Valley of California with San Joaquin half to the south and the Sacramento half to the north. Well, if you look at the vegetation of California, it's also very complex, not nearly as simple as what you see in the east. There is a desert area, there's a forest area, but there's a lot of complex vegetation in between. Well, if you look at the kind of climates that you have east of the Rocky Mountains, like at New York City, you have a measure of temperature here at the bottom, that kind of a raised up area. That's temperature that goes from cold at either end to warm in the middle. And the upper part is rainfall. So it rains pretty much all year round, although some of that's in snow during the winter. So there's plenty of water available in the hot part of summer, so that just when plants need to grow the fastest, can grow the fastest because the temperatures are warm. They have plenty of water to help them do that. And that's why, because that kind of climate is widespread in the eastern US, forests are widespread all the way from Florida to eastern Canada. The species change a little bit, but it's forests all the way from Florida up to Ontario and west to even Iowa and even into eastern Texas. Well, if you go a little further west, the rainfall goes down, but it's still concentrated in the summer, just at the very best time for plants to grow. When it's the warmest here, it's the rainiest also because it's midsummer. And that means for all the way from central Mexico all the way up to Saskatchewan, you have great grasslands reflecting that climate where they get plenty of rain just when they need to grow the fastest. Very consistent vegetation, very consistent climate. But boy, when you get out to California, it's very different. The rain here is falling just at the time when plants have the hardest time growing, when it's the coldest. And when it's the hottest here, when plants like to grow, there's no more rain. So they've got this very tight little window between when the rain stops and it starts getting hot, when they have to do their growth. That's the springtime that's so beautiful here in California. And it's right at this checkpoint here between the end of the rainy season and the beginning of the hot season, which plants create a lot of the plant diversity and some of the characteristics of our plant life here in California. So for example, we're known all over the world for our great wildflower shows. And you can see these flowers are all flowering at once, very showy flowers. Well, they have to be showy because they have to flower in that brief little window of time between when the rains end and it starts getting too hot and dry for growth. That's the time they have to attract the insects to pollinate them all at once in a very short, brief period of time. So if you're out, you can see a lot of beauty, and it's only there for a short period of time. Not like the East Coast where it's trees can be there all year round and grow, but not flowers are pretty scarce. Same way in the Great Plains, there are a few flowers, but nothing like this. None of the great flower shows. In fact, a man from England went around the world looking for the best places to see wildflowers, and he singled out California as one of the best places in the entire world for wildflowers. And it's interesting that because pollination is so critical here in this one little window of time, this has been a great place also for the pollinators. In most of the world, the biodiversity of ants is the greatest of all the insects in the Hymenoptera. But here in California, the biodiversity of bees is greater than the biodiversity of ants, presumably because we have so many flowers that need to be pollinated all at once. Another thing about that is that there needs to be a place for that water to be stored. It falls in the winter, and then it's used in the spring a few months later. So where that water falls can make a huge difference. And that's one reason we have so different kinds of vegetation right next to each other in the same climate. Like here's Cache Creek. One side has green grass and blue oaks and manzanita. The other side has gray pines and chaparral. Well, this one of the reasons it's so different is this is an area of serpentine, so that unusual chemistry created by collisions that brought the metal to the surface are here. But it's not just serpentine that creates those great differences in vegetation. Here's a place with no serpentine at all in May, not too far from Yolo County. In the foreground, we have coast live oaks, and the grass is all brown in May. Same time of year, same moment in time. In the background, the grass is still green, but there are no trees. What's the difference? Well, it's a very important difference because in the foreground, you have volcanic rocks with big cracks so that the water that falls can go down deep away from the roots of the grass and down to the roots of the oaks. In the background, we have Eocene sediments that are rich in clay, and the clay holds the water at the surface so that the grass can stay green longer, but it cuts off air to the roots of the oaks, so that's a terrible place for trees to grow. The only place they can grow is in ravines where there's been enough erosion to break through the clay and create a kind of a riparian forest. Well, in California, we get our biggest rainstorms from those atmospheric rivers that come from the southwest. So southwestern arriving rain is hugely important for the distribution of biodiversity and especially plant life here in California. So if we look at elevation, if you look at the southern end of the Sierra Nevada, you can see it's colder. It's higher, excuse me, not colder. Yeah, I'll talk about that in one of the later maps. But it's higher than the rest of the Sierra Nevada. It's the highest extensive part of California. And wherever there's mountains, though, you see a certain amount of elevation. The Klamath Range, the volcanoes of the Cascade Range up here in northeastern California, the little Warner Mountain Range here, the northern part of the Coast Range, and then you go down the southern Coast Range is relatively low until you get down where the southern Coast Range, Sierra Nevada, and the Southern California mountains all come together in a kind of a forgotten range called the San Emigdio Mountains. And they, even though the Sierra Nevada gets into Kern County, the highest point in Kern County is actually in the San Emigdios near Mount Pinos. And once again, you can see high elevation areas in San Gabriel Mountains, San Bernardino Mountains, the San Jacinto Mountains, and then further south, the mountains are a little lower. And once again, this big low spot in the middle of California, the Great Central Valley, which is almost entirely unique on Earth, is such a great valley, completely, with the exception of the Golden Gate, cut off by mountains from the rest of the landscape. So you can see how that affects the January mean temperature. If you look carefully, you can see that high area in the southern Sierra Nevada is actually colder. It's a little slightly different color than the rest of the mountains, which are still cool, but it's even colder in that southern part of the Sierra that's so high, Sierra Nevada that's so high. So this is one place you actually go south to get colder in January. And then you can see the same thing in the Southern California mountains. They're high enough to create January mean cold, but you can see relatively warm temperatures along the coast in January, and also on the southern part of the desert, the Sonoran part of the desert, separated from Southern California by the Peninsula Range. If you look at the July mean, you can see a big breakup in the temperatures that are very high in the San Joaquin Valley, and once again, quite high in the Sacramento Valley, but a break here because of the sea breeze. We get the Delta breeze that comes in from San Francisco Bay, causes a break in summer temperatures that we really appreciate. But as you go north, this is one of the places, just like it's odd that it gets colder in January as you go south in the Sierra Nevada, it's kind of unusual that it gets hotter in July as you go north. As you get up to Redding, it's much hotter than Sacramento. And once again, in July, very hot in the California deserts, but especially hot in this. You can look at near the Nevada border, there's kind of a ribbon of bright red. That's the Death Valley, which actually in July has the highest July that have ever been recorded on Earth, meaning it's hotter there in July than any place in the Sahara Desert, much bigger desert, anywhere in the Atacama, the driest desert. The only place that are similar are the Tigris-Euphrates Valley in central Iraq and Pakistan. And they both have the same reason that temperatures are so high in July. You notice it's, if you look over at the far map to the left, it's completely surrounded by mountains in elevation. Well, anytime wind blows down a mountain, it gets compressed and it gets hot. So a place like Death Valley that's very low, completely surrounded by mountains, no matter which way the wind blows, it gets compressed and it gets hot. And you get the same thing in Iraq because it's got mountains to the west. Same thing in Pakistan, as it also has mountains to the west. And the wind in the northern hemisphere and southern hemisphere as well blows predominantly from the west. Both of those are hot, but they're not as hot as Death Valley. We don't have any place known on Earth that's as hot in July. It's the only place on Earth that averages over 102 degrees centigrade for the entire month of July. And then if you look at precipitation, you get the reverse. Instead of precipitation being high down in the southern Sierra Nevada, where the mountains are highest, it's highest up in the northern Sierra Nevada. The brighter red or orange it is, the greater the precipitation. And it's also high up in the northern Coast Range into the Klamath Mountains and also into the Cascade Range. Well, especially for that northern part of the Sierra Nevada, southern end of the Cascade Range, that's the result of those southwestern storms coming through that break in the Coast Range at the Golden Gate and hitting directly into the northern Sierra Nevada and the southern Cascade Range to produce very high rainfall. And it also goes up the Sacramento Valley and hits the extension of the Klamath Range where it meets the Cascade Range, and you get a lot of high precipitation up there, just right next to the July mean being very high on the map to the right at the same place, right around Lake Shasta. And that's an interesting place because a botanist found a plant there called Shasta snow wreath that had never been seen before, a brand new endemic, only around Lake Shasta, only place it was known anywhere near California. But it did have a close relative. It turns out that its nearest relative was a snow wreath in the same genus in Alabama, another place that's very hot and wet. So because we have hot temperature in the northern Sacramento Valley reaching the Cascade Range in the eastern part of the Klamath Range at the same place, only place in California where it's hot and wet, in some ways just like Alabama, except it has a Mediterranean climate, but it's so hot and wet that this relic from probably a different climate has been able to survive in this one little spot in California that makes that spot a little biodiversity hotspot. And once again, you can see rainfall in the North Coast Range generally gets darker and wetter as the mountains get higher. But if you look south of San Francisco Bay, you can see some little yellow spots indicating higher rainfall around Santa Cruz. And there's redwood forests in the Santa Cruz Mountains. Those southwestern arriving atmospheric rivers hit the Santa Cruz Mountains and create enough rainfall for an isolated grove of redwoods, a redwood forest in the Santa Cruz Mountains. And then if you go further south, there's a break and you see the same kind of yellow south of Monterey. And once again, because of the Santa Lucia Mountains, they also stop those atmospheric rivers enough to produce enough rainfall for the kinds of redwood forests you have along the northern part of Big Sur. But the higher mountains in Southern California, though, they stop those atmospheric rivers so that the southern end of the San Joaquin Valley is just as dry as the Mojave Desert and the Sonoran Desert. And there's a little break there because of the Tehachapi Mountains. But the Coast Range is stops enough rain that you have desert conditions all the way from Bakersfield north to Fresno. Well, if you look at temperature variation, the difference between July and January, you can see that those extreme hot temperatures in Death Valley create extremes. The winters are cold and the summers are the hottest place on Earth. And that's that great difference in temperature from July to January. But you see green all along the coast, and that is the coastal influence caused by fog, so that the summers are cooled by fog along the immediate coast, and the winters are also protected by the moisture from getting extremely cold, so that the difference between summer and winter temperatures along the coast in places like San Francisco is some of the least extreme anywhere in North America. And you can kind of see that fog effect here. Lots of fog up in the northwest and patches of it along the coast showing as green. But you notice it extends outward from the Channel Islands, and there are areas of warmth around the Channel Islands, breaks in cloud cover. And that means that because the fog tends to stay seaward from the Channel Islands, it allows a large area off Southern California to be warmer than anywhere else along the coast of California, because it's protected from the cold currents that bring the fog down from the north. And it's an area called the Southern California Bight, which Bight is B-I-G-H-T. And that's an area where you can get isolated tropical fish like flying fish and Garibaldis because the water is so warm. But if you notice south of the Channel Islands, that cold starts getting closer and closer to the shoreline. And by the time you get down to Ensenada, that fog reaches the land again, so that you get some of the same fog belt plants that are found further north, like at Pacific Grove and San Francisco, reappearing around Ensenada, like the coastal pine forests that are typical of the Monterey Peninsula. And then there's the monsoon rains I mentioned that come from the Mexican mountains. And they bring thunder and lightning with them. The brighter red to the southeast, that's areas closer to Arizona, and they bring more of that monsoon effect. And it, because it hits the Sierra Nevadas, those high, especially southern end, you get a lot of thunder and lightning there. And you get enough summer rain from this monsoonal effect, not only on isolated mountain ranges in the Mojave Desert, like the Providence Mountains, but you also get them along the eastern slope of the southern part of the Sierra Nevadas, so that you get the only place in California where you get dominance by the genus birch, Betula, and it's actually dominant from those summer rains that come in from the Arizona monsoons and hit the southern corner of the Sierra Nevada. Well, California, the main part of California has lots of different kinds of vegetation because it has lots of different kind of local geological conditions and climates. You get chaparral, you get oak woodland, and then one of the interesting things you get in the Central Valley are riparian forests, and because they are able to tap water that flows down out of the mountains in midsummer, ecologically, they don't have a Mediterranean climate. So they can get trees related and other plants related to things that are normally found in the eastern United States. And you have a lot of deciduous trees associated with these riparian forests, just like you have deciduous trees in the east. They can grow fast in the summertime, so they can rest with dropping their leaves in the wintertime. And then we have great marshes. A lot of them are gone, but we still have some. They were very widespread in, especially in what we know of as the Delta in California, which is actually a big freshwater marsh. It's not a typical delta at all. And this was the great home for tricolored blackbirds, and places where it still survives is still a home for tricolored blackbirds, almost a California endemic bird. But up there in the mountains, like the Klamath Mountains, the Cascade Mountains, the Sierra Nevada mountains, you get pine forests and mountain meadows. And you get the same kind of pine forests in those high mountains of Southern California, like the San Emigdios, the San Gabriels, San Bernardinos, and the San Jacinto Mountains. And you get places where you get even enough ice, even with a pretty warm climate, for some of the ice and snow to hang around all through summer. And we still have a few tiny glaciers in the southern Sierra Nevada. Well, here's our redwood forests, and a lot of people think of these as fog forests, but this is an area that gets almost no fog at all. It's well inland from the fog. The one characteristic, other than not being terribly cold in the wintertime, that indicates redwood forests is plenty of rain. Rainfall above 40 inches per year on the normal. And you get the same thing in the those islands of redwoods south of San Francisco, like the Santa Cruz Mountains and the Santa Lucia Mountains. You have to get close to the coast to get what looks like, in a lot of people's mind, to be a rainforest. But you can tell it's actually not a rainforest, it's a fog forest, because just like you get cloud forests with lots of epiphytes in tropical mountains, you get the same thing in the fog belt along the California coast. Lots of epiphytes in that narrow fog belt, following the California coast all the way down to Point Concepcion with its own group of trees. And the trees there are various pines, Monterey pines and bishop pines, not redwoods. Also, you get Sitka spruce is another one that's favored by the fog belt, not so much redwoods. One of the most characteristic plants that follows the fog belt and doesn't get inland at all, except where it's planted as an ornamental is California wax myrtle. And most of the forests of wax myrtle have been destroyed, but here's a nice one near Bodega Bay that's completely intact, totally dominated by California wax myrtles, right in the fog belt that's on the outer coast at Bodega Bay. Then, of course, we have our deserts, very dry, very hot. In the southeastern part of California, completely different than our redwood forests or our montane coniferous forests. And then if you go further northeast of the Cascades and the Sierra Nevada, you get cold deserts like those in the Great Basin, dominated by sagebrush. We don't get a lot of the Great Basin in California, but we do have some valleys like the Sierra Valley where it can be found. Well, John Muir, actually right here in California, started the concept that things shouldn't be there for our use and we can destroy them, biodiversity at our own choosing, because it doesn't matter. It's all something there for our use. And this message couldn't have come at a more opportune time, because that was the time when our bison were being destroyed on the Great Plains, our passenger pigeons were being shot out of the sky and went from being the most abundant bird in North America to being extinct. Well, John Muir said, things have value and they should be preserved for their own sake, not just because it's something you can kill and use. It made a huge difference. And that idea that started here in California with John Muir now has gone around the world to create national parks. And all the ideas like 30 by 30 really go back to John Muir's legacy of ideas. Well, back in 1868, right after the Civil War, before that, he had walked from the around Indiana and Kentucky down to the Gulf, and said that there was lots of grass, but very few flowers. 1868, though, he came out to California and walked across the Central Valley when it was not full of irrigated agriculture and towns, and said this was something different that he'd never seen before. Flowers everywhere, miles and miles of flowers, and a few grass species among the flowers, but mostly flowers in 1868. And then when he went up to the mountains and came back in the fall, he saw flowers again, but they were completely different. The late summer and early fall flowers, like this Holocarpa virgata that he walked through, were kind of smelly, but they were beautiful in their own way. And all the flowers they'd seen in the spring were gone. And the Central Valley had things like vernal pools that are better developed there than any other place on Earth. And back then, before the irrigated agriculture in towns, there were things like the San Joaquin kit fox there in the San Joaquin Valley, burrowing owls, which are disappearing very fast. I've seen them disappear in Yolo County to the point where it's very hard to see even one now. It used to be common when I first moved here. And back in John Muir's day, there were even pronghorns through the fields of flowers that he found in the San Joaquin Valley. They disappeared by the 1930s. The last ones were seen, but now they're actually being reintroduced in places where the San Joaquin Valley wildflowers still survive, like Carrizo Plains. You can still see ones that are introduced from the Great Basin in Carrizo Plains. Well, one thing that the World Wildlife Fund said about the Central Valley of California, that John Muir was the first one to really describe in English. All Spanish explorers had seen the same thing John Muir saw, and we had a professor from UC Riverside that looked into the Spanish archives and found that they saw the same thing John Muir saw. Fields and fields of flowers, beautiful flowers, went on for miles. Well, the World Wildlife Fund said there'd been so much change in the Central Valley of California that it was the most endangered ecoregion that they could find anywhere in North America. And it was so endangered that there were no natural areas left in the entire Central Valley. Well, that's a bit of an exaggeration because Tuleyome has looked hard and we found a few natural areas, or at least places where the native plants and animals have been able to survive. And we found one of these at a place that we call Woodland Regional Park and Preserve, and we're in partnership with the city of Woodland, Tuleyome, lots of volunteers from the Rotary Club, and they've made this little piece of surviving Central Valley into a place that's a great environmental education center for the kids of Woodland. People love to come here. It's beautiful. We're coming up to a great spring thing event there. It just now, for the first time, put in its welcome sign at its entrance. A great victory that was an idea that originated with Tuleyome. And a little bit of riparian forest even in the background. Well, one of the things that helped us preserve this is palmate birdsbeak, federally listed endangered species, almost driven to extinction in the Central Valley, only in the Central Valley endemic, but it survives here, and thanks to the good stewardship that the volunteers at Woodland Regional Park and Preserve have done, they've doubled the population of this extremely rare, close to extinction plant at Woodland Regional Park and Preserve, thanks to their good work. Another plant that is very beautiful and was actually the first one to bring Woodland Regional Park to our attention is alkali milk vetch. Beautiful little plant, also on the verge of extinction. Unfortunately, we have less than 100 at Woodland Regional Park and Preserve. So, and it's a real California endemic because the only places it survives are in spatial habitats between the metropolitan area of Sacramento and the metropolitan area of Oakland. You couldn't imagine a worse habitat, endemic habitat for a rare plant. And we've seen it disappear in so many of those places that are marked on the map as former habitat. Well, Woodland Regional Park protects less than 100 of this beautiful, extremely rare species, alkali milk vetch. But the environmental impact report for a project near Davis recently documented 19,300 individuals of this species, which is one of the largest known remaining populations on Earth. Unfortunately, the project proposes its destruction. And this is the project plan. It would completely pave over and destroy one of the largest known populations of alkali milk vetch. And it's not only a biodiversity hotspot for alkali milk vetch, it has a federally listed endangered species there. It has many other rare species and is a great foraging area for rare raptors that use its open areas to forage. All that would be wiped out if this plan goes through as it's intended. So if you care about saving biodiversity, there are global efforts like 30 by 30 that I mentioned at the beginning, but you can start here at home. If you'd like to help save the biodiversity threatened by the Village Farm Project, please contact me at holstein@cal.net. And so thank you for joining me tonight. And if you have questions, I'll be glad to the extent we have time, to try to answer them. But maybe you can stump me. I always like people with a hard question that I can't answer. That's the way I learn new things.
So thank you very much, Glenn. If you have a question, you could put it in the chat, or you could just say in the chat, I have a question, and then I'll call on you and you can unmute yourself. But I'll start with a couple of questions. First of all, I want to make sure everybody knows where the Woodland Regional Park and Preserve is. It's on the corner of Road 25, County Road 25 and County Road 102. So most people know that as the road that you would drive down to go to Costco. It's on the right side. That's where the Woodland Regional Park and Preserve is, and that's where we're going to be having the spring thing coming up on March 22nd. The next question, Glenn, could you go back to that map of the Village Farms project and point out the streets so everybody can know, really where that is?
I don't know.
Oh, here we go. Yeah, we were able to go back to it. The southern edge, where it's kind of curved, that's Covell Boulevard. The area to the southwest is the cannery area that where there are a variety of homes and parks in the former cannery location. And the eastern edge is Pole Line Road, which to the north becomes Road 102.
Okay, thank you.
The problems with this, that area just to the north of it is the former dump for Yolo County, and there were lots of toxics dumped there, and at very low elevations in groundwater, only about 8 feet down from where they're planning to put houses, is toxic groundwater. So I don't think the people that would potentially be living there would want to have a home improvement project and dig down into toxic groundwater. So that's another problem. It's much better to save this area as a biodiversity hotspot right in our backyard. And there are plenty of places that don't have these biodiversity issues close by, that don't have any biodiversity issues at all, where the same kind of housing could be built without creating and destroying a biodiversity hotspot like this one would. Yeah.
Okay, since I don't see anybody else asking a question, I'm going to ask another one. So for biodiversity in California, at the very beginning, you did mention that there was also biodiversity in fungi and
Kelp.
and kelp or algae. Can you talk a little bit about that?
Yeah, we have some of the most outstanding kelp forests in the world. We have not only the largest trees in our redwoods and our sequoias, but we also have the world's largest kelp. And this is extremely important for our fish diversity, our crab diversity. And one of the things that, because the sea otters that were eating a plant that, a invertebrate animal that eats kelp, this is the sea urchins that eat the kelp have grown to huge proportions. So it's very important to increase our number of sea otters so that they can eat these sea urchins, so our kelp forests can survive. And they've actually diminished quite a bit, and all the biodiversity associated with them can also be lost as well. Now, with fungi, one of the reasons that it's less looked at in biodiversity is that it can spread very rapidly by spores. It has tiny spores for the most part in our mushrooms. And so if you have the right habitat in many of these species, you can find around the world. So we actually keep better track of plants and vertebrate animals than we do. And we're starting to finally do that for insects, but it's difficult for insects because there are so many of them. We mentioned how bees are so biodiverse compared to ants here in California. There's a little bit of a study like that, but overall, there was even a great clouds of gnats that came out of the Yolo bypass, and only about 10 years ago was it found to be a new undescribed species. So there's still an awful lot we need to know about insects. But one of the things about areas that can be, species that can be counted for biodiversity is they need to be able to be seen and counted. One thing that makes it hard for to do that with fungi is the fruiting bodies that we see in mushrooms are only at the surface. Most of that fungus is underground in the mycelium, and it only kind of pops up briefly when it's wet enough. So we definitely have a lot of mushroom diversity here in California and diversity of other fungi. But in many cases, these same species can be found thousands of miles away because spores can move so far. Whereas the seeds of plants don't move as far, certainly mammals don't move as far, so they're much more likely to be endemic than mushrooms are.
Okay, I'll ask another. How about lichens?
What's that? Oh,
How about lichens?
yeah, lichens. There is a lot of biodiversity in lichens. One of the great places for lichens is the fog belt. We have huge development of lichens, and lichens are kind of an unusual kind of plant. They're actually mostly fungi, but they're an unusual kind of fungus because they have a green alga that they coexist with that enables them to get out of that underground area that most of the fungi have to live in, and they can be out in the open air with the mosses and even in bright sunlight. For example, there was a beautiful orange lichen that was found on rock outcroppings around the edge of the Central Valley, and it was actually named by a visiting lichenologist that came out here from Kansas. And he says, "You've got the most striking lichen around the Central Valley, and it doesn't even have a name yet." And he named it and described it for the first time. So because they don't quite fit in the fungi and they don't quite fit in the green algae, because they're species that include both, but they're really starting to be looked at much more by the mycologists, the people that study fungi now. Before it was just lichenologists that studied them on their own, but really they're mostly fungi, but they're fungi that can live out in the drier climates or foggy climates and get up where plants can grow because of the algae that are inside them. Just like there are algae that corals are dependent on in coral reefs. A lot of times, a lot of animals and in this case fungi depend on these green algae, which are not higher plants. They don't have the vascular system of higher plants, but they have the same kind of photosynthetic mechanism, and they're probably the old-time ancestors that led first to mosses and then to the higher plants that we think of as our wildflowers and trees.
Okay, we have a question from Terry, and the question is, how are extremely rare plants encouraged by conservationists to build their populations?
Well, there's various ways they can be encouraged. One of the things that the volunteers that work up at Woodland Regional Park and Preserve are doing is protecting them from being crowded out by exotic plants from all over the world. And we've, because we have a Mediterranean climate and agriculture is actually originated in the Mediterranean climate of Southern Europe, North Africa, and Southwestern Asia. There are a lot of plants there that are very adapted to disturbance. And when they've managed to get to California, they just take off because they're adapted to our climate and they're also adapted to disturbance, which was very rare earlier in California's history and now has become very common, especially in the Central Valley. So we have some very aggressive plants. One that's brand new actually made it into the listings of California plants just in my career as a botanist is one called stinkwort. When we first found it, it looked a little bit like some of the native plants that show up in late spring, and it has similar ecology, but nobody knew what it was. And we actually identified it because it had also invaded Australia, but it turns out it's native to the mountains of northwestern Africa, where if there are floras, they're in French, so a lot of people were not familiar. So we actually found out about it from botanists in Australia, where it invaded first. And I actually followed its introduction. It was first introduced in Santa Clara County, and I've seen it spread now all through the Central Valley and become one of the commonest introduced plants, and one that threatens our rare species. Another thing that you can do is control these invasive plants by grazing. A lot of times, the grazers will actually take more of the invasive plants than they do of the native plants. And actually, that was one of the things that really helped that native relative of the phyllories. Now, the phyllories can tolerate light grazing, but very heavy grazing takes out the competitive non-natives, and actually the little native phyllory needs that to survive. And one of the reasons that we were able to protect it was it became available, but some people thought it was too heavily overgrazed. Well, because it was heavily overgrazed, the botanist Ellen Dean went up and found this is the place where rare plants are common, because it had been so heavily overgrazed, it had knocked down the invasive plants that had crowded out some of these rare natives other places. But because of what was called overgrazing, it formed a great habitat, and they really thrived in the so-called overgrazed area.
Okay, I don't see another question, but I thought of another question I'm just curious about. You talked about how much we don't know about biodiversity, for example, insects. It occurred to me, what kind of biodiversity might there be in microorganisms in our different climates and all the different animals and plants, and what kind of microorganisms might be associated with them?
Well, there certainly is we're finding every time that we take a new measurement of what's called environmental DNA out of the ocean, we find DNA for species that have never been seen before macroscopically or even under a microscope. We see their DNA because we can measure it, but we don't know really where the organism is that it comes from. So there's a whole world out there that we're just now, thanks to DNA exploring of microorganisms, we found a whole new group, a whole new kingdom called the Archaea that in some ways are more closely related to our group than the more typical bacteria. And that was found relatively recently. And the discoveries there are coming up very rapidly. But because the microorganisms can move around the world so readily, they're probably going to be less likely to be endemics. They're more likely, if they are endemics, they're likely to be endemic in a particular habitat, like a hot spring or something, and maybe nowhere else. A kind of example how a hot spring can lead to endemism are Wilbur Springs up in the county to our north, in Colusa County, actually has an endemic species of fly called the Wilbur Springs fly, found nowhere else in the world. That's nearest relative are the great clouds of black flies that feed the gulls around Mono Lake. But very close to that, but nowhere else is the same species found, but Wilbur Springs hot springs.
Okay, thank you very, very much, Glenn. That was a great talk.
More questions from the audience?
There are no other questions in the chat. Oh, here we go. Once again, very interesting and enlightening presentation by Dr. Glenn. I had no idea. I had no idea there's a native vetch from Keeley. Yeah, I think we're all aware of that invasive non-native vetch.
Yeah. Was that a question, Bill?
No, no more questions.
Okay.
So thanks, everybody. Yeah, I guess we'll just close for tonight.
Well, thank you, Bill, for hosting, and thanks everyone for sharing this talk about biodiversity with you. It's a pleasure chatting with you tonight.
And I'm going to share the screen one more time so you can have another chance at that QR code if you want to give a donation, or you could go to the website, the tuleyome.org website. Okay, good night, everyone.
Good night.